This is Rick's RoTs, rules of thumb on how to make effective use of MySQL. I'm going to go rapidly through 100 or more tips, one-liners. I'm going to start with some things having to do with indexing, move on to character sets, Galera, datatypes, etc. Wide variety of things. These things have come from answering thousands of questions on forums and seeing what people make mistakes with. Okay, a mini lesson in indexing. Indexing, of course, is the way to get selects to be sped up, but indexing is not a panacea. You can't simply add a bunch of indices and hope that things work. You need to look at the select and decide what index is needed for it. Everything's a B tree, or virtually everything, and that's a good all-round way of, good all-round index type. When building an index, start with any columns that say column equals constant. Put those in the index. Do not have a column hidden inside a function call. Instead, turn it around so that the column is by itself and then you have the function outside. Flags are hard to optimize. An index probably won't be used for a flag. You get to use only one index per select. But that index could have multiple columns. That's called a composite index, and that's usually a good solution. Index prefixing is bad. It often doesn't get used. And it's wrong if you try to prefix something and then say it's unique, because you're only getting the first 10 characters being unique. A composite index on A and B is not the same as separate indexes on A and B. Some are better in some situations, some in others. In particular, the first column or columns of an index, well, index AB will take care of things that index A would take care of, but it won't help you if you just need to look up by B. Don't have too many columns in a composite index. A covering index is where all the columns mentioned in a select are mentioned in the index. The reason this can be beneficial is that it doesn't have to jump from the index to the data to do the work. Like I said, these are one-liners. I'm not going into sufficient detail to explain them all. You can certainly come after me some other time. An index is shunned if it doesn't, if the value you're looking at is very common. You've got a true-false flag, and it's half true, half false. It's going to just scan the table rather than using the index. That's equivalent to what I said before about don't index flags. Don't use force index. That'll work today, but it'll screw you up tomorrow. There are exceptions. Okay, I've got several sections, like 8 or 9 sections. I'll entertain one question after each section and then more questions at the end if we can manage. So, first of all, let me say the index cookbook, which matches the index talk I gave yesterday, is over there. Any one question right now? Going, gone. Optimization. Some things are not good optimizations. For example, subqueries may or may not be useful. Some people coming from other database systems love to write subqueries knowing that their optimizer will do a wonderful job. MySQL does an iffy job on subqueries. You can usually turn a subquery into a join, and that's usually optimized much better. Even in 5.6, which will automatically generate indices on the subquery, well, that's extra effort. You're still better off turning it into a join if it works that way. In select, that's getting improved. Try to avoid it for now. However, a subquery with a group or group by or limit shrinks the number of things, and that may actually make using a subquery more efficient. I'm sorry, some of this is hand waving. We need specific examples, which I'm not going to give you, to say, here's a good one, here's a bad one. A trick for OR. First of all, OR is terrible on indexing and efficiency. It essentially can't use indices when you have an OR in the where clause. One trick is to turn it into a bunch of selects combined by union. So you do one of each of the ORs as you go along. It's clumsy, but it may be a lot faster. People always say, oh, panic, I have a temp table and a file sort. That's the end of the world. It's not. First of all, file sort doesn't necessarily mean you're touching the disk at all. What this usually means is you have a group by or an order by. You explicitly said, I want to sort the data in this order, which is not natural otherwise. Well, okay, you're going to have to save the data, sort it, then deliver it. There are workarounds in some situations, not all. Clustering data. If you're doing a range key, a range where clause, on the primary key is clustered with the data. This means that consecutive rows in the data are consecutive in the primary key, and you're doing a range such as where the primary key between this and that, then it will be presumably quite fast because you get one block in, you've got maybe 100 rows before you have to read the next block. If you're jumping around the table, such as with UUIDs, you're IO bound. Could be bad. Rule of thumb, you might get 1,000 queries per second. If you're getting less than that, well, maybe you need to look at some things. If you're getting more than that, good for you. You don't need me. The slow log is the best clue on what's going wrong in your system, performance-wise. Turn on the slow log, set the long query time low, and collect the stuff. Then use something like PT Query Digest to summarize it and say, here's your worst query. Here's the second worst query. Look at those two, and probably speed up your whole system significantly. Another thing that people goof with is they say select distinct and then have a group by at the end. Distinct and group by sort of do the same thing. Don't mix them. Another tip, when you say union, explicitly say all or distinct. The default is distinct, which means take a second pass over the data to dedupe it. Second pass, temporary, file sort, etc. A little bit of extra time. If you know the pieces are not going to be duplicated, say all. It'll be faster. And if you say distinct, then you know you thought about it. If you are joining a few tables and then you say group by, there's a pretty good chance that the sum or count you're doing with the group by is going to overcount. It's going to first explode the number of rows because of the join, then do the summation, and then collapse it again, do the group by. You may be getting the wrong answer and you may not know it. This particular thing can be hard to work around, but sometimes can be. If you got 1,000 rows, ignore all this. If you got 1,000,000 rows, you should be studying all this. If you got 1,000,000,000 rows, you need more than I'm telling you. I have a rule of thumb and my own my own personal work, and that is, if I don't see a path to saving 10% in whatever I'm working on, don't bother. Go look for something else. I don't look for 1% savings. The exception is get the data types right up front, because it's hard to change them later. You make everything big int because, well, what the heck? You're wasting most of 8 bytes, because you don't really need big ints most of the time. Normalization, do it, yes, but don't overdo it. One particular thing not to do is normalizing dates or floats. Anything continuous, any numeric-like thing, don't normalize it. Because someday you're going to want a range on that, and if it's sitting off in that normalization table, performance will go out to lunch. Protect against SQL injection. If you're running a website, somebody someday is going to come along and hack into it, and there are easy ways to hack into it if you don't escape the data that came in from a form in HTML before handing it off to MySQL. Rule of thumb, if your NODB transaction takes longer than 5 seconds, rethink it. Do it some other way. You don't want to be hanging on to things that long. Okay. May I ask you to find your smartphone thing and be ready to rate this thing, because we're at the end of the session and you're going to run out of here and forget to rate me. But anyway, any questions so far on this section? Nope. We're going to get through to the end. Partitioning. Are you sure? Has anybody done partitioning? Has anybody thought about it other than you two? Chances are you didn't need that partitioning. But there are a few use cases. Did you have 1 million rows? If it's less than that, it's hardly worth it. Did you have one of the few use cases? Did you use by range? Did you? By range, or as opposed to by list or hash. Hash is essentially useless. Subpartitions are useless. I have a section, this is the section on it. You can't get unique keys, you can't get foreign keys, so that's a restriction. Sometime in 8 they might have it. We'll see. Here are the 4 use cases. Sliding time. You got data coming in all the time, and you want to throw the old data away. Drop the partition. The drop partition is much more efficient than a delete. 2-dimensional index. Find the 10 nearest Starbucks to where you are. You can't do that with a regular index. You need something extra. The other 2 are pretty obscure. I have a blog on it. There'll be a link later. By range, no subpartition. No index should start with the partition key. This is because you've already pruned by the partition key. Why waste your effort now further digging into an index the same way? Put the partition key at or near the end of the composite index, whatever indices you have. Now this thing about auto increment. Everybody thinks auto increment, it's got to be a primary key. False. The only rule is that it must be the first column of some key. Doesn't have to be unique, doesn't have to be primary, just some key. This applies for non-partition as well. If you have less than 20 partitions, why did you bother partitioning? If you have more than 50 partitions, you're getting into overhead of that's 50 tables, that's various other things that can provide extra overhead, slowing you down. 8.0 with its data dictionary may improve things. Don't know yet. Okay, you want to hit me on partitioning? Any questions? There's a discussion of this section spelled out at length. Character sets and collations. It's unfortunate that the move from Latin 1 to UTF-8 was so painful, and now the move to UTF-8 MB4 is going to be painful again. 5.6 screwed it up pretty badly, and fortunately 8.0 will be defaulting to MB4 and a decent collation. So people by default in the future will have a good setup. Terminology. Capital UTF-8 is what the rest of the world calls the standard. MySQL started with the 4-letter UTF-8, which was a subset of it, and is trying to extricate itself from the mess that made. Unicode is not UTF-8. They are highly related. You can say this Unicode code number matches this byte sequence in UTF-8, but they're different things. Character set is not collation, another common mistake. UTF-8 MB4 is a character set, UTF-8 MB4 underscore something or other CI, that's a collation. In the future, simply use UTF-8 MB4 for anything text, almost anything. That's the last half of this slide. In particular, for emoji and some Chinese characters, you need the 4-byte UTF-8 MB4. ASCII or Latin 1 is fine for hex strings, such as GUIDs, UIDs, various digests, IP addresses, country codes, postal codes, things that are always just English letters. Furthermore, most of those are short, fixed length, so those are about the only examples where char is reasonable instead of varchar. If you need to debug a character set problem, do these. There'll be clues to get somebody else to help you. There's no other viable way to see what is actually stored other than using hex, selecting hex. If you try to print it on the screen, you've been through the browser and who knows what else, and some of the browsers try to fix the mess you have. And it looks right, but it's wrong. After years of futzing with this, I came up with 4 categories of problem. If instead of senior, with the accent over the end, you get one of these 4 cases, those are the main 4 cases I see. If it turned into a question mark, you've lost the data, but we can say, okay, this went wrong, trying to store the data. If you come up with those 2 characters instead of the 1, you got emoji bait or double encoding. Can't tell the difference from here. That's where the hex, select hex, would further define it. If the browser displays a black diamond with a question mark, that's another case. If it truncated it, well, you've lost some of the data. All right, best practice, if you're starting from scratch, this is the screen to read. Outside, make sure your UTF-8 in your bytes, in your editor, in your client, whatever the outside world is. When connecting to MySQL, use the API-specific connection function that lets you say either UTF-8 or UTF-8 MB4, however it runs, or you can fall back on set names. This says that the client is using UTF-8 or UTF-8 MB4, and the server, well, it doesn't matter what the server's going to do, because it gets translated on the wire. Translated as you insert, as you select. But you got to tell MySQL what those bytes are going to be. And then, with an extra less than sign, typo, declare your column or table to be UTF-8 MB4. That's best practice. It could be Latin 1 if you're only doing Latin 1 stuff. Doesn't matter. In the case of HTML, most browsers now default to UTF-8, so this meta statement may not be necessary. The form except is saying when somebody types into that form, treat them as UTF-8 characters so that it gets injected the right way. Collations. Notice, all of these are the character set followed by something else. The bin collation says just look at the bits. It doesn't know that capital A and lowercase a are going to be the same. General CI will not do much more. It'll do case folding and accent folding. Unicode, that dates back quite a few years. Unicode 5.2.0 is newer, and the 9.0.0, which is available in 8.0, is a still newer Unicode standard for how characters should be compared. This takes care of various odd characters, anyway, complicated things. The most complicated, perhaps, is where you have a combining accent and a letter. It's two UTF-8 characters, but they're treated as one. AE with the versus the ligature AE may or may not be treated as the same character, depending on the collation. .5.6 had a problem with UTF-8 MB4. WordPress is stuck in the mode of not only providing this problem to you, but not providing a solution. The problem was that MySQL had a limit of 767 bytes for any column in an index. Here are five workarounds for it. Character set questions. First, okay, what do we have? Stack Overflow, that's a rundown on the black diamond and the four cases. What went wrong doing them, and the bottom one is a link to how to fix them. No, that's a list of collations. What is equal to what or greater than what? Question for character sets?
I keep hearing differently about whether using general or Unicode impacts performance. What is your thought?
Item 1, the impact is minor because fetching the row is the major part of the action. Secondly, I hear from Oracle, with a biased opinion, that they have 10x or better performance improvement in collations. So use the one that's appropriate for how you want things sorted, compared, ordered by, etc. Some people are using only Polish, say, so they want the Polish collation. Fine. Or the German phone book, or as opposed to the regular German, or whatever. Galera, alias, Percona extra DB cluster, or for that matter, this MariaDB has cluster included now, and you can actually tack Galera onto Oracle MySQL. A few notes on it. The programmer needs to remember to check for errors on commit, because certain deadlocks, etc., only show up at commit, not earlier. In any multi-master situation, you need to understand that auto-increment numbers will have gaps, not be consecutive. There are cases where a multi-node Galera setup will actually be faster than what you had before. If what you had before was clients far from the master, and now you've pulled the master close to the client, it could be that you're running faster. The best HA, high availability, is 3 data centers with at least 1 node each. For the critical read problem, in other words, you post a comment to a blog, you turn around and get to the next page and you try to see your comments and it's missing because replication hadn't gotten there yet. This one-liner is the fix for that. It's unique to Galera. Who knows what Oracle's group replication will do? They haven't figured it out yet. Therefore, I'm not ready to recommend group replication. Here's a common trick. You take a node out of rotation for backup, testing, upgrades, alter, whatever. Do your thing, put it back in, and it resyncs. Magic, sort of. What are the competitions? Well, I was just debating at lunch about MHA and Orchestrator, so I'm not sure if it's in the right place. Anyway, I like Galera-based things. Group application is coming on strong. Fabric is dead. MHA and Orchestrator do some things, but not everything. Dual master, there are just too many problems. Don't do dual master. Question? Galera? Moving on. More details on converting. Data types. Let's do it right to start with. Use a date time, not 2 columns, a date and a time. There may be exceptions. Usually unsigned is appropriate. Not null is usually appropriate. That's just a little bitty thing when you want to check for overlaps, just a coding trick. If you're coming from somewhere else, a sequence sort of is replaced by auto-increment, but you got to do a lot of extra work. And MariaDB has sequence tables, which are nifty. With CTEs, which Oracle has in 801, you can do something like it, but it's 10 lines of code. Int, paren, 2, int, paren, that 2 means nothing. You could say int 100, still nothing different. Int is 4 bytes, 2 or 4 billion limit, depending on what's signed or unsigned. You want a 2-byte integer? Tiny int. Tiny int unsigned, probably. Big int takes 8 bytes. Don't use float or double for money. You got round-off problems. Use decimal. Never use float with the precision stuff on it. What's it for? Don't say varchar 255 all the time. Put something reasonable there. The arguments for this are minor. It's an overhead in certain situations, like temp tables in the middle of a select, hidden inside. Adds to the overhead, adds to whatever. And I already mentioned varchar versus char. GUIDs, etc. Because of how random they are, if your table or that index is bigger than you can cache, you're going to be I/O bound, and guess what? You're dead sooner or later. I mean, if you've got a terabyte table and suddenly every reference is an I/O, how many terabytes, how many I/Os can you do per second? Not enough for what you want. IP addresses, why var binary 39? You could pack it into a binary 16, a lot less space. And in the process of packing, you can get it so you can compare them, CDRs and whatever. Don't put credit cards, SSNs, etc. in. You got serious security problems. This is not MySQL advice, this is legal advice, which I can't give because I'm not a lawyer. For latitude and longitude, if you go beyond 4 decimal places, you're talking about comparing hairs. Question on data types? Goody. So more on IP ranges and latitude, longitude. Miscellany, well, tips on various things, how to do it. Pagination. Oh, but I'm using this offset limit. Why is it so slow? And they haven't gotten to the point where there's a bug in it. If somebody inserts or deletes a row while somebody else is walking to the next page, they could skip or duplicate a row. Remember where you left off. That's the bottom line of it. There's a link later of more discussion of that. For fast inserts, load data is the best. Next best is batching the inserts. A single insert statement can have any number of rows in it. You're saving various aspects of overhead when you batch them. But rule of thumb, 100 to 1,000 rows per batch. This makes it replication friendly. It balances the number of transactions. You get a transaction that's too big, it's got some extra overhead. This is a good size. You're into the range of diminishing returns. I mean, 10,000 is not going to be noticeably better than 1,000. 10, 1,000 chunks. Delete. Again, chunk it, or use drop partition. Chunking on the primary key is better because you're nicely walking through the table. I like this pattern for doing a where clause on dates. Dates, date time, timestamp, all of them work identically. You have the same starting date. First one is I'm starting with that, and the second one is I'm starting with that plus some number of hours, days, months, whatever. And it takes care of not including the midnight of the end, taking care of leap days and year end, and it even handles microseconds. So one pattern for all of them. Summary tables for data warehousing. That's the secret sauce. Need I say no more other than how the heck do you do it? Already said don't normalize dates and floats. In MariaDB, column store, and TokuDB are possibilities. They handle things differently, and part of their secret sauce is significant amount of compression. Compression in big tables means less I/O. I/O is the critical path, therefore, yada yada. But summary tables, that's a 10x improvement over any other thing you do. Key value pairs, yuck. So my advice on that is keep out some of the columns that you need for searching on. Throw the rest of the junk, the sparse data, into a JSON blob. Question on this section? Well, first of all, okay, that points to 14 things, including the lat long, the pagination, the key value, etc. Boy, no questions today. All right. Hardware. It's a one-time fix. You can't raise your hardware again tomorrow. So why bother doing it? Got to work on these other problems too. But so fix the schema. If you can cache things, that helps a lot. When you're timing a select, you have two possibilities. I'll see how long each one takes. If you use SQL no cache in it, then you're saying to avoid the query cache. Now, in general, for production systems, turn off the query cache. It's in the way, it slows you down, it's got problems. But if you happen to have it on, this takes it off. Run the query twice. First time we'll do other types of caching. The second time will be a realistic estimate of how long this query takes. Now, second run of two possible selects, now you have a valid comparison. Which one runs faster? In the long run, performance is about counting the disk hits. On HDDs, you don't get much more than 100 reads a second. You get a lot more in SSDs. I don't have a good number to put on this slide because they keep changing, they keep improving. RAID speeds things up some because you get striping, assuming you're doing the striping aspect. That helps. Battery-backed write cache makes it appear that writes are instantaneous. This is great. What's really happening is it's going into RAM on the controller. It's got to be a controller, not simulated in the operating system. And if the power goes out, it's still available even if it hasn't been physically written to the disk. So it's safe and fast. Don't bother saying, I'm going to put this table here and that index there and whatever. It's not as good as RAID striping. SQL, MySQL, uses only one CPU for a connection. Partitioning, union, they don't help. Still, one CPU. You got lots of cores, well, you can make use of them if you have lots of connections. If you got a high CPU, you've got a slow query, work on the query. You can't get faster CPUs today. You haven't been able to get them since the last century. Used to be the CPU speeds went up all the time, now they're flat. Composite index is often the cure for a slow query. If you got high I/O, there may be some tuning, there may be some schema changes, there may be index stuff. Some people say XFS is the best file system for Linux. Okay. This first item is getting kind of old because, thank goodness, virtually everywhere the buffer pool is large enough so that that's not your stumbling block. Used to be the performance, this would be one of the first things to look at for performance. If you had a tiny buffer pool, it was struggling and swapping and, well, not swapping, but thrashing. So 70% of RAM for the buffer pool, unless you have a tiny VM, better make it a smaller percentage. Because if you swap, it is bad. Other tunables, don't worry about them, at least not to start with. Query cache, turn it off, totally off. That means two settings, the type and the size. If you don't turn them both off and restart, you will have something like 11% overhead on queries, just because it's there waiting to be used. Okay, that's a blog on limits. Any questions on hardware? Yes?
Can you just talk for a second about ext4 versus XFS?
I don't know enough to give you a solid answer. ext4 is at least in the top section. ext3, no. All right. Miscellany. This is the last section, and we have 9 minutes left, so we're doing good. 1,000 queries per second, said that. So log is good, said that. Don't have 1,000 databases, don't have 1,000 tables in a database. You're straining the operating system if you have 10,000 of either of those, because things are implemented as files. 8.0 with its data dictionary will slightly improve that. If you have Max clients is an Apache option. Other browsers, other servers have other things. If you let hundreds of connections come through to MySQL, then MySQL will start stumbling over itself. It may be better to throttle back how many connections you can make. And that's throttling back at Apache or whatever. If you're going to ask somebody for help, don't describe the table. It's not as descriptive as show create table. Don't do select star, except when you just want to dump the table and see what it looks like, or you're bringing it into a hash and you're going to use it with associative memory lookups. The reason for this is tomorrow you're going to add a column and suddenly the array that you get back is not quite what it used to be, and your code will break, and you may not know why. Don't say count star, or sorry, do say count star. Don't say count column name. With the column name, it's going to check that column for being null. Maybe that's what you want, but the standard usage is count star. Don't mix group by and distinct, that's a duplicate. And the join and group by. Got some duplicates. Load average, it might tell you a thing or two. I don't like it. Profiling and what got replaced by it using the performance schema usually just says one of two things, copying data or something dumb like that. No clue as to what it's really doing. Why is it copying data? Why is it whatever? If you have threads running going above, say, 10, then it could be that you have contention and it could be problems. Pick a number. The more cores you have, probably that should be larger. MySQL is not a good queuing engine. So rethink whether you want to have a table designed for queuing. I like to say, don't queue it, just do it. Instead of putting it into a queue and then later pulling it out and having to mark it done, blah, blah, blah. Maybe it works better to simply launch the thing that will do it. There are exceptions. If something's locked, look for what else is in the process list. Now, maybe you can't find it. It could be something that is busy scratching its head but has a begin but not yet a commit. Or maybe it's an auto commit equals 0 and you forgot to put a commit somewhere. I dislike auto commit equals 0 because it begs you to forget to close the transaction. And there you are hanging onto it till whatever. Depending on what you're doing, combine the alters into a single statement. If it's going to have to copy the table over, it's better to do it once rather than once for every thing that you're trying to do. Add a column, drop an index, add an index. Do them all at once. When it copies the thing over, it creates the new table with the new schema and then copies the rows one by one or whatever in batches. PT online schema change, or as I'm learning today, Ghost is a good alternative to alters. But there are limitations. MyISAM, it's going away. Don't use it. Anybody using it now? Deliberately? No? Okay, good. If you need to convert, that's tips on it. Okay. Any questions on this section? Or better yet, rate my session, ask more questions. Here's some links you might like. First link is these slides, which should be available someday from Percona. Rick's RoTs. The other thing is an old version of this. There's an email, there's a website with a bunch of things. How many which? Transactions with commit, with
Would fail to commit. Blocking the
there's so much variety in where that happens that no, I would hate to try to enumerate them. Things that fail to commit. Now, the thing I was pointing out there is coding errors that opened a transaction and then spent too long getting around to committing, as opposed to as opposed to a deadlock or a wait timeout. There are two things that are likely to occur even in good code. One is a deadlock where they can really see you have two connections connecting locking rows in opposite order. That's a deadlock. If they're doing it in the same order, well, one of them will get it and the other one will delay. So those are the easy ones. Deadlock, just rerun the transaction. Delay, you won't even notice it because it's automatic. In the case of Galera, you don't notice the deadlock until commit, even though it could have happened earlier. Questions?
I was just going to say, another reason why a transaction might not commit at the end is if ops or DBA kills it in the middle.
Also, a network glitch could pull the rug out from under you, at which point you've lost all your variables, you've lost various things. You should not have auto recommit turned on, because now it's reconnecting in the middle of a transaction. Half of it's gone because it failed, and you're starting over, sort of. Another rule of thumb I should add. More? Okay, thank you.